This is Proof of Proficiency, or POP, Part 2, Scripts and Production. You will need the following materials before you get started: a printout of a math flow map and blank script, or a printout of an ELA flow map and a blank script. Participants will be able to create their own POP script and create their own POP. Let's focus on one objective at a time. First, participants will be able to create their own POP script. Before we look at some scripts, please note that these are examples of scripts. As a teacher, you can add or eliminate pieces to work best for you and your students. Let's see an example of an ELA script. When you watch this video, look for: what do students need to include in this ELA POP script?
Right now we're working on the ELA POP script, which includes, it's like the math POP script, except you have your name, you have your standard and the standard description. You're supposed to highlight the parts of the standards that you're focusing on in your video. You also want to make sure you have like focus statements, like the purpose of the standard, how you can find the theme, or how you can find parts of the standard, or like anything that's relating to the parts that you highlighted. So like I highlighted the determine a theme or central idea. So one of my focus statements was how you can find the theme of a text. One of my focus statements was the purpose of the standard, and analyze its development and analyze its relationship to the characters. I also included the key part to the theme of the text and how it develops as the character, so you watch how the characters are changing. You also want vocabulary, so when you're teaching your standard, whoever's watching the video, you don't want them to be confused. You want them to know what the words mean. You also want to So we've been doing questions. We've been writing questions and answers on our standard on the book, The Merry Adventures of Robin Hood. And we're going to use two of our best questions to explain the standard.
Please pause this video to reflect on the question, either aloud with a group or silently by yourself. Now that you've had a chance to reflect, I heard the students say that the scripts include the standard, standard description, objective, focus statement, and vocabulary. The script also includes a question based on a book they are reading that relates to their standard. Then they answer that question in detail. Now let's see a script for math. When you watch this video, look for: what do students need to include in this math script?
So this is where our circle map is. This is where we take all of our notes and information about the standard that we're learning about. So then we move on, and these are our vocabulary words, and this is our introduction. And then we're adding this new this year, and we're adding common misunderstandings, which is where you find a common mistake with a problem that you might be doing, and you have to tell the viewer why it's a common mistake. On here we're doing a simple example problem, and it's where we show the viewer how to solve a problem like one in the standard. And then on this page we do another one where we have them solve it, and then we also help them out in the end with that too. And then finally we have our conclusion page where we pretty much say our conclusion and where we write that out. And then on the end we have a checklist, and that's how we know that we have everything done with our POP.
Please pause this video to reflect on the question, either aloud with a group or silently by yourself. Now that you've reflected, we see that a math script includes a standards research circle map, the objective, vocabulary, common misunderstandings, a simple problem and answer, a real-world problem and answer, and a conclusion. Here is a science script. When you watch this video, look for what do students need to include in this science POP script?
So this is our science pop script. First we put our name and then we introduce ourselves, our 3 names with no last name from our school, and in our objective we put the objective. Every single time we have a different objective, and right now it's Unit 1 Cells and Concept 3 from the NGSS Science Standards. So for the next page we have to do 1 question and 1 race answer. I'm in the process of writing the race answer from these 3 notes, these 3 questions that I took. I'm doing this question right now using all these notes to put it into 1 answer. This is my script for the POP video. On the next page we do the second question, which is going to be this question on my tree map, and I'm only going to write a summary, not a full-on race answer using these notes, and the same thing goes for question 3. The next pages just have extra question sections in case there's more questions. And then we have our conclusion where we say our concept again and restate it in a different way and explain what we've learned in the video. And then we have our rubric, which we just check off of to make sure we did everything in the POP video. And that's it.
Please pause this video to reflect on the question either aloud with a group or silently by yourself. Now that you've reflected, we see that a science script includes an objective and multiple questions based on their readings. They must include a detailed answer for one question and summaries for the other questions. Remember, these scripts are examples and can be modified to fit the student's needs. Here's a teacher exemplar of a math POP script and an ELA POP script. What do you observe? pause this video to reflect on the question either aloud with a group or silently by yourself. Hopefully you noticed that a lot of writing and editing is required. Each section is very detailed, and there is a checklist at the end to make sure all components were addressed. Why is the script so important in the making of the POP? Please pause this video to discuss with a group or silently reflect. Scripts are important because without the script, the POP will feel unprepared. The script provides word for word what the student will say. Without it, students may fumble over words as they record. So we've come to our first core idea. The script provides writing and editing practice for the students, and an exemplary script is key to making an exemplary POP. When creating a POP for the first time, there are a few things that are helpful to remember. First, you want to be as detailed as possible. Set your expectations high for yourself and for your students. During the process, give glows and grows constantly. Let students know when they meet your high expectations, but also let them know where they can improve. In-the-moment feedback is the most beneficial. Also note that students may struggle at first to create a really well-produced POP. Just know that the POPs will become better and better as students get the opportunities to work on them and the amount of high-quality feedback from you. The best way to fully understand the components and efforts it takes for a student to create a script is for you to create your own script. First, choose a subject, either ELA or math. Then, choose a standard to research and focus on. You could go to the Common Core website to choose your standard. If you choose ELA, you may write your question and response based on any book you've read, or use the passage and questions provided. Use the flow map to help keep you on track for creating your script. Pause this video to work on your script. Please pause this video again to share and discuss your scripts with your group. Here's the math exemplar from the See It video. Here, the presenter researched the math standard. In this case, it is a 5th grade standard, NF1. Students can include example problems, vocabulary, or anything that helps them understand the concept. This presenter researched this standard using IXL, Khan Academy, and teacher-made slides and questions. Here's the start of the script. Students introduce themselves and the objective they will be showing. This page also includes vocabulary and any common mistakes made. This part of the script shows a simple example problem. The problem is solved and the student is required to write out their explanation. So, for example, this presenter's simple problem was 1/2 plus 3/4. After she solved it, she wrote, "Our first problem is 1/2 plus 3/4. I can see I don't have common denominators. Let's find the least common multiple between my denominators of 2 and 4. I can see the LCM, or least common multiple, is 4. If I multiply 1/2 by 2 over 2, I get an equivalent fraction of 2 over 4. My new equation is 2/4 plus 3/4. Now that I have a common denominator, I can find the sum. 2/4 plus 3/4 equals 5/4. I can check my answer by drawing a model to represent my fractions. I also got 5/4, so I know I solved it correctly." The presenter literally writes out step by step how she solved the problem. Then, students create a real-world problem. Again, they solve the problem and write out their explanation in detail. Please pause this video to read and reflect on the detail this presenter included in their writing. The final piece concludes the script and reiterates the objective and how it relates to the real world. The presenter wrote, "Now you will be able to add fractions with unlike denominators. You will use this standard in the real world like Sally did. She added 2 different amounts of liquid and needed to know the total amount of liquid. When you have 2 amounts of liquid and the fractions have different denominators, now you will know how to add them. Now let's look at an ELA exemplar. This is where the student looks at the standard and chooses an objective to focus on. In this case, it is a 4th grade standard, RL3. Vocabulary is defined so the student can fully understand the objective. The POP will be based on a question related to a novel or passage. Both are written at the bottom. Please pause this video to review each section. This is a double bubble map showing the similarities between 2 characters in the passage. The presenter read the question and read the text. As they read the text, they took notes on this thinking map. The question was based on the standard they researched. Here's the start of the script. Students introduce themselves and the standard. Academic vocabulary is given and the grade level text that will be used. This is where the student introduces the question that is based on the standard. The student also writes a detailed response citing evidence from that text. The presenter wrote, "In order to address this standard, let's look at a passage called Running Like a Pro by Aditi Shriyam. We're asked about a father and son's similarities. Julian and his father have a lot in common. What evidence from the story supports this statement?" The presenter then responds with a detailed, evidence-based answer. Julian and his father are very alike because they both have hazel eyes and big ears. They look so alike that people would say to Julian, quote, "Aren't you a spitting image of your dad?" Quote, paragraph 1. Both Julian and his father also like to run. According to paragraph 2, quote, "When Julian's father began training for a marathon, Julian found himself wanting to run as well," end quote. This evidence proves that not only do Julian and his father look alike, they also like similar activities. Finally, the student shares the connection between the question and the standard and concludes the script. The presenter writes, "This question helps us show mastery of the standard because we are giving specific details on a character based on physical and personality traits. We discuss in depth about Julian's qualities and can make a picture in our minds about what he looks like. Now you will be able to describe a character drawing on specific details from the text." Let's reflect on the script writing process. Please pause this video to complete the multi-flow map. The event is students create a detailed and well-written POP script. What would the causes be? Please write them on the left. And what would the effects be? Please write them on the right. Our next objective is participants will be able to create their own POP exemplar. You will get the choice between the Explain Everything app, Powtoon website, Google Slides, or Prezi. You will be watching 3 exemplar POPs, 1 math, 1 English, and 1 science. When you watch these videos, think about, how do the speakers sound on the videos, prepared or unprepared? Why do you think that? And what makes these videos engaging to a viewer? As you watch, write down what you observe. I am Miss Corral from Navigator Schools. This is Standard 5 NF1, and in this video you will learn how to add fractions with unlike denominators. You will need to know a few academic vocabulary words to help you understand this standard. The first word is sum. The sum is an answer to an addition problem. So I have 2 apples plus 1 apple equals 3. 2 plus 1 equals 3. 3 is the sum. Our next word is fraction. A fraction is parts of a whole. It contains a numerator and a denominator. Here are some fractions written in number form, and here are some fraction models shown. Our next word is numerator. Numerator is how many parts we have. It's the top number of a fraction. Another important word is denominator. The denominator is how many equal parts in a fraction. It's the bottom number of a fraction. Our last vocabulary word is least common multiple. This is the smallest multiple between two numbers. So for example, if I was looking for the LCM of 2 and 6, first I would need to write out the multiples of 2. 2, 4, 6, 8, 10, and of course I can keep going. Now let's do some multiples of 6. 6, 12. Oh, but I can stop because I see that I have a common multiple already. The smallest common multiple is 6. So the LCM of 2 and 6 would be 6. A common mistake is adding the denominators. Don't do it. 1/2 plus 3/4 does not equal 4/6. You must find a common denominator. So our first problem is 1/2 plus 3/4. I can see I don't have a common denominator. Let's find the least common multiple between my denominators of 2 and 4. So my multiples of 2 would be 2, 4, 6, 8, 10. I'm going to stop there. And my multiples of 4 would be 4. But I can stop there because I'm looking for the least common multiple. I can already see that they have 4 in common. 4 would be my LCM. If I multiply 1/2 by 2 over 2, that gets me to my denominator of 4. And when I multiply by a fraction that equals 1 whole, I'm not really changing the fraction. If I multiply my numerator, 1 times 2 equals 2. So 1/2 has now turned into 2/4. If I multiply 3/4 by 1 over 1, because that will get me my denominator of 4, and again, I'm multiplying by a fraction that equals 1 whole, not really changing the fraction. If I multiply my numerator, 3 times 1 is 3. 3/4 actually stayed the same. Now that I have a common denominator of 4, I can find the sum. 2/4 plus 3/4 equals 5/4. I can check my answer by drawing a model to represent my fractions. 1/2 has turned into 2/4. 3/4 stayed the same. I also got 5/4 as my answer, so I know I solved it correctly. Here's a real-world problem for you. On a hot day, Sally poured 9/10 of a bucket of water into a plastic wading pool. A few minutes later, she added another half of a bucket. How much water did Sally pour into the pool? First, I need to understand the question. I know that 9/10 and 1/2 are important numbers. I also see a key word, added. This tells me that I need to add my two fractions in order to find the total amount of water that Sally poured into the wading pool. I know that when I add fractions, I need a common denominator. I don't have that yet. Let's find the LCM between our two denominators, 10 and 2. I can see that my LCM is 10. That is the denominator I need. If I multiply 9/10 by 1 over 1, 10 times 1 gets me to my common denominator of 10. 9 times 1 equals 9. 9/10 actually stayed the same. And if I multiply 1/2 by 5 over 5, 2 times 5 gets me to my common denominator of 10. 1 times 5 gets me 5. So 1/2 turned into 5/10. Now my new equation is 9/10 plus 5/10. 9/10 plus 5/10 equals 14/10. I can check my answer by drawing a model to represent my fractions. I can see 9/10 has stayed the same. 1/2 has an equivalent fraction of 5/10. 9/10 plus 5/10 would equal 14/10. I can see that my answer is the same. So to answer the question, Sally poured 14/10 buckets into the plastic wading pool because once you find the common denominator, the sum between 9/10 and 5/10 equals 14/10. Now you will be able to add fractions with unlike denominators. You will use the standard in the real world like Sally did. She added 2 different amounts of liquid and needed to know the total amount of that liquid. When you have two amounts of liquid and the fractions have differing denominators, now you'll know how to add them. Thank you for watching.
Created using Powtoon.
Hi, we are
Jason, Nicole,
and Orlando from Navigator Schools. In this video, you will learn about kinetic energy. You will learn about the relationship between kinetic energy of an object, its velocity and mass, as well as how it's transformed into potential energy.
a few vocabulary words you need to know are force, the interaction that causes a change between motion of objects. Velocity, the speed or direction of moving objects. Acceleration, a change in velocity.
Kinetic energy, the energy an object has because of its motion. Potential energy, the amount of energy that's stored in an object. So you can see here, the ball will have more kinetic energy, and the balloon has potential energy stored inside of it. What is the relationship between the kinetic energy of an object and its velocity and mass? The relationship between the kinetic energy of an object and its mass and velocity is the energy of motion. According to Discovery Textbook, the kinetic energy of the object is dependent on the mass of the object as well as its velocity. If an object has a mass, m, and a velocity, v, then its kinetic energy, ke, is as follows. Ke equals mv squared divided by 2. This shows that if an object is moving forward, it is dependent on the mass and its velocity to increase the amount of kinetic energy. For example, if both of these vehicles were traveling at a speed of 50 miles an hour, the truck would have more kinetic energy because of the bigger mass. Also, if the vehicles accelerate, the kinetic energy of both vehicles will increase.
How is kinetic energy transformed into potential energy? Kinetic energy is transformed into potential energy by using force. When an object in motion stops moving, it loses kinetic energy. For example, when you stretch a rubber band, its potential energy is released. Rethinking everything we have learned, we have shown you how kinetic energy works.
You have learned that the relationship between the kinetic energy of an object and its mass and velocity lies within its energy of motion and force, and how kinetic energy is transformed into potential energy.
Please pause this video to discuss these questions based on the See It videos. How did the videos look? Prepared or unprepared? And why do you think that? And what makes these videos engaging to a viewer? Now that you've had a chance to discuss, hopefully you noticed that the videos looked and sounded very prepared. The only justification for this is that the presenters must have written a very detailed, thorough script. The videos are engaging because pictures and colors were used, and the speakers spoke accurately without stumbling over their words. The production method, an app called Explain Everything, and a website called Powtoons are just a few examples of how to make an engaging and visually appealing pop. Now let's discuss why the output of production is beneficial for students. Please pause this video and discuss with the group the following question. Why is it beneficial for students to show proficiency of a standard using POPs? Now that you've discussed, we saw how engaged the students were and the collaboration that came along with script writing and pop creating in part 1 of this professional development. Students are motivated with this type of learning. Students are using many forms of technology to produce wonderful work which sharpen tech skills as well. But probably the most important reason students should be creating POPs is because according to Bloom's taxonomy, creating, designing, and developing is the highest level of learning. So we've come to our second core idea. POPs increase student engagement and collaboration, as well as provide application of the standards using technology. When students are ready to produce their POP, they need to know how to use the program you want them to produce on. If they've never used the Explain Everything app, they won't know how to record, edit, or add pictures. These are skills that need to be taught and practiced. Also, don't try to teach all the programs at once. Have them master one program by practicing, and then you can introduce the others, such as Powtoons or Google Slides, at a later time. Now it's time to practice. You will use your script from earlier to make a pop on the Explain Everything app, Powtoon website, Google Slides, Prezi, or any other similar app or website you choose. If you are unsure of how to use these programs, please refer to the resources at the end of this PD for how-to videos. Make sure your pop includes all parts of your script and your pop is around 5 minutes long or less. Pause this video so you can create your pop. Let's reflect on the script writing and pop process. Please pause this video to complete the tree map. What are the necessities to create an exceptional script and pop? If you're unsure of how to use any of the following programs, please refer to these how-to YouTube videos. Thank you for watching the Proof of Proficiency, Part 2, Professional Development.